heading the lab, heading the department for a while, heading the research group, and so on. But I was also a visiting professor 2 times at University of Johannesburg. That was 10 years ago, in 2011, 2013. During one of these meetings or visits, I met also Professor Mpofu, and we made some contacts. And then later he came to visit my lab. He spent few months, I think, on a sabbatical. And yeah, that's it. And now last year, he also invited me to join the Gibela Research Chair as a research advisor. And what I'm also very proud of, I'm a fellow of the International Academy of Production Engineering, CRP, which is the leading institution in the field of manufacturing or production engineering. So my research fields are very broad in more than 40 years of work, of course, but the main topics are manufacturing systems and mechatronic systems. But we were also a lot doing with information system, with business engineering, with remanufacturing, and so on and so on. So here is a short list of some projects from the last 10, 15 years. Many of them are of international character. That is the, character of European, especially small European nation. So we are always looking to find partners also overboard, on the other side of the borders, and trying to cooperate on a bigger scale. I also obtained some innovation awards and recognitions. I don't want to go into these details. Perhaps there will be some time at the end to show you some of the results of these innovations. Okay. I was also a part of some success stories in the past. Okay. The content of my talk, I would like first of all to point out why research in manufacturing is so important, and what is the background of contemporary industrial production, and why do we need some changes now. We will talk also about the global initiative in manufacturing, which is called Industry 4.0. We will talk about the key technologies, and I will show you some cases from our university industry collaboration, from our projects. So what is the role of manufacturing systems for national economies? I think that manufacturing of products and goods for general industrial and personal use is becoming the most important activity in the world, because it's generating quality of life. For citizens, it's contributing to continuous growth of wealth, as well as power and position of states. And this value-creating and job-creating activity deserves strong and continuous labor of all actors of the modern society. And these cognitions make our research in manufacturing even more exciting. And that's why we can put our efforts and contribution in new perspective. I borrowed these slides from my friend, late Professor Cheng from the Hong Kong University. It is showing on the global level how the shares of generated global production output changed in the last 250 years. Okay, it's a long period of time, but a lot of things happened during that time. And of course, we can see now what is happening now. There is a big rearrangement of these shares. We can see that old economies like Europe is losing. We can see that also the United States is losing. And on the other side, that the Asian economy, especially, of course, China now, and North and South Korea and Japan are growing very, very fast. So why research in manufacturing is so important from our European perspective? In average, in European Union states, 27 of them, the average contribution of manufacturing industries to gross domestic product is about 20%. In Slovenia, it's even higher. We estimate it's about 25%. Globally, it's about 16%, and I believe that South Africa is also somewhere here. 16–17% of GDP is generated in South Africa by manufacturing industry. And I think there is a lot of potential to increase this share and to bring some more wealth to the country. Of course, in the recent decades, the globalization process was very, very strong, starting in the 90s and still going on, but with some disruptions now. And we can see some really winners in that period of time. Perhaps some, let's say, so-called Asian tigers, like South Korea, like Taiwan, like Hong Kong, Singapore, and so on. But first of all, China is really generating now, and it is dominating in the manufacturing sector, especially in some, let's say, domains like electronic productions, software as well, and so on. And these two examples can be taken as role models for others, that this kind of development can happen very, very fast in a decade or two. Look at China, that really happened in the last 2 decades. So what about the old Europe? We see that in the last decade, the data are from 2001 and 2012, there are many countries decreasing the share of GDP coming from the manufacturing industries. There are only few winners, like Germany, of course, and Czech Republic, Poland, the new countries in the European family, Switzerland, of course, but all others are decreasing the share. So this is a big potential for Europe. Why this is important? Because manufacturing industries are employing people, and almost 40 million people are employed by these industries in the European Union. And we have to be aware that each job in manufacturing industry is creating 2 jobs in the service sector connected to this industry. And, you know, I remember 20 years ago in Europe, in Brussels, they were discussing about that, you know, manufacturing is becoming obsolete, that it should be relocated, it should go out, and we should be more service-oriented economy with perhaps some micro and nano technologies and so on. But later, some colleagues of us from universities, like Professor Giovane from Politecnico di Milano and Professor Weisgeber from Stuttgart University, try to convince politicians in Brussels that this is not the case, that in Europe also the traditional manufacturing is very important. And this awareness really changed in the last 10 or 15 years, because there is a recognition that Europe will never become a competitive knowledge-based economy without strong and competitive manufacturing industries. But these industries must be transformed, and they should not rely so much on the natural resources anymore, but they should rely on knowledge and innovation. So these are the recent cognitions which are very important for all of us. But to follow this, the industry has changed radically in Europe in the last 10 or 15 years in terms of much higher productivity and strong innovation and considerable orientation of the workforce and capital investment. And there are many new products being developed, and there are many new markets opened in the recent years. And it is recognized that manufacturing productivity is the motor driving the European wealth creation. And what is very important, that this productivity was increased for about almost 50% in the period of between 1995 and 2007, in comparison to our big competitors, where this productivity gain was not so high. On the other side, we are facing globalization, and the globalization is opening new markets and new opportunities, but also bringing some problems, of course. There are, of course, the interlinked supply chains now in the industry. And what is also important, the industry was hit by the most severe crisis in the living memory that happened in 2008 and 2009. And this impact of this crisis was really serious by affecting the output for about decreased for about 20%. There were some years of recovery between the period of 2014 and 19, but after that, we were facing the pandemics of the COVID-19. And recently, what is really affecting very much the economy, the business state in Europe, is the war in Ukraine. So these are really destructive elements now affecting our industries. Okay, so let me go further on. What are the most significant issues for the European industry? So on the one side is the need to benefit from the opportunities of new international markets. There is the key role of the single market. The single market having about 500 million of population. It's a big, huge market, still defragmented, but with the potential to get more united. It is recognized the importance of technology and innovation, and in particular of key new technologies and ICT. There is a big need to improve energy and resource efficiency, and to make this transition toward green economy, toward low carbon economy. Of course, there is recognized importance of supply of raw materials. The need for restructuring to ensure adequate access to finances, to money. And of course, there is a big need to skill transformation, to transformation of knowledge and skills needed by today workers. We are facing the transition from working forces toward knowledge forces. There is recognized the increased role of business services and the importance of the favorable environment for business and entrepreneurship. And of course, there are emerging social challenges, such as demographic change. For example, in Slovenia, we are facing this elderly of population. There are not new kids coming out. And that is a big problem, of course. We are getting old, we are getting gray-haired, but not enough young people to do the business, to do the work. Okay. What is the current situation in industry? I am following industry for 3 or 4 decades already, and we are still noticing that the industry is still running on the basis of well-known but obsolete concepts and models. There are still rigid hierarchical structure, typical for the organization. Relations to our customers are predominantly based on buy-sell relationship. The focus is on optimization and not on innovation. The first reaction to globalization was relocation of work-intensive production toward the low-wage countries. But with this, also some knowledge flew out of the continent. And the role of knowledge is not recognized yet properly.
We are back on screen now, Prof.
You see my screen now? I don't see it on the screen.
Yes, we can see it. So you can continue with your presentation.
Okay. So the situation is like that. The industry is still working on this obsolete concept, and that's why we think there is a need for a new manufacturing paradigm. I don't see my screen. Okay, now I see it. Okay, thank you. So what is the situation? We are still working on the basis of the methods of work, which was developed 100 years ago by Taylor, the principle of scientific management. We know the principles of lean production coming and being developed in Japan in the mid-50s and 60s, also 50 years ago. They are also becoming obsolete. But on the other side, we have a lot of new developments in science. We have new cognitions and new technologies which are being intensively developed. And especially the information and communication technologies open new possibilities. And on the other side, the world has changed. It has become global, open, and competitive. But now, due to the circumstances, it's getting close again. So, it's a kind of dynamics we can observe. And it also has been recognized that one has to deal with very limited resources. And we have to be much more careful regarding the natural equilibriums. And on the other side, of course, the manufacturing itself has become much more complex as it was in the past, in the times of Taylor, which I already mentioned. So we have to be aware that we cannot, make a big step at once, but we have to do stepwise. New technologies in implementing, adopting in industry, and then in parallel, new technologies are coming out. So we have to understand this kind of, steps and follow these steps by implementing and adopting new technologies. For example, we can see that the production has changed in the last 100 years very significantly. From the Ford times where only price and productivity were important. Then in the 70s, flexible production was introduced, enabling variation of products and flexibility. In the 80s, the quality was pointed out as being one of the most important characteristics in production. In the 90s brought us agile manufacturing. That means time responsiveness. But what we are talking today about is we are talking about personalization, about singularity, about innovation and learning. I think these are the key characteristics of contemporary production. Okay, so we are talking about innovation. And the role of innovation is to restructure manufacturing industries, which contribute to the GDP, as we already learned. And of course, we know innovation of products, we know innovation of process and technologies, but we have to take to consider also innovation in business models, in organizational models, and so on. And last but not least, also in education. For example, and I can perhaps talk about it sometimes in the future, we developed a project-oriented education in mechatronics with our students, where our students were working in teams of 4, 5, up to 10 students, because industry is supposed to work in teams. And they were developing real products, of course, with limited resources, but that's also one of the problems which students have to learn. So I think this was very innovative concept 20 years ago, and we published some work on that. I don't know if my colleagues are doing that way, but there were some also now, but there were some changes in the curricula, so you know, things are changing, but the experience was very good. So what are the objectives of innovation in manufacturing industry? The objective is to develop and reinforce economic potential, and thus the economic power of the state. The objective is to increase productivity and thus faster generation of wealth. The objective is to raise competitiveness of our industries and to rationally solve the problems of unemployment and other social related problems, and the deficit of qualified experts on the other side. To establish human working conditions, that's also very important. And automation helped us a lot in the last years to make work much more human, and thus to improve the quality of life. I will skip this table, but it's very interesting. I borrowed this from the source in Business Week, but it is showing how the fundamental changes are going on in contemporary business. It is being turned around from top to bottom or bottom to top. For example, the structure of organization of companies, from the rigid parity into the network organization, for example, and so on and so on. There is a lot of these characteristics shown here. And if you think and go through this, you will really recognize that this is being changed. And also in the manufacturing paradigms, we are also changing from the Tayloristic paradigm towards the more emerging paradigm based on, you know, biological patterns, based on evolution, recovery, self-organization, and so on, recognizing that the human subject is a competent with a person with different abilities and competencies, and that these differences are really generating development forces. We know from physics that, you know, the potential difference is bringing some force. In electricity, in mechanics, and so on. It's also in the social life. And we also know that the production is always on the edge of chaos. I was working in industry in an engineer-to-order company with almost one-of-the-kind production. And the situation was really sometimes chaotic, especially on Monday mornings. But okay, you have to solve the problem in any case. And of course, what is also important that the manufacturing is becoming a hard science. Okay, so we are now facing a new industrial revolution. It is called Industry 4.0. And it's very interesting that this term, Industry 4.0, was proposed by our German colleagues, engineers and scientists, because they were searching for, motivation for their politicians to put more efforts on to recognize the importance of manufacturing industries. And if we go 10 years back, we can remember it was a deep recession at that time. The industry was really suffering. And this was a kind of, motivation to get it moving, to put some additional efforts and money, of course, into development of new technologies and, of course, new paradigm. So it was really an idea to trigger a wide campaign of research, development, and innovation in academic institutions, as well as in industry, in the fields of manufacturing, to contribute to change, encourage perception of industrial development in the eyes of politicians and in the general public of the global scale. And I remember really, the general public was never informed so much about the manufacturing industry. For them, the industry was always something, far away and dirty and so on. But through this campaign, the public and especially the politicians were much more aware, getting aware about the importance of manufacturing industry. So this Industry 4.0 the idea now is converging into the new industrial paradigm, which is really reshaping the research, development, innovation. People are already talking about Industry 5.0 or Industry 6.0 and so on and so on. But these are some ideas. I remember I was working on my PhD on computer integrated manufacturing 30 years ago. So that was at that time also a very advanced concept based on advanced technology behind. And, after this really in technological push came some ideas about, anthropocentric systems. So anthropocentric meaning that people should be put more into front of technology. And we are now being aware that, also in Industry 4.0, that the people, the workers, the scientists, the engineers play a vital role. So we have to consider this. But their role, I will show you later in a slide, their role is being changed rapidly in this concept of Industry 4.0. Here is the definition. I won't go into this definition. I will skip it. Okay, this figure is also, okay, there is some delay in the, okay. What's going on now? Sorry.
Everything is in order, Prof. You can go ahead.
I'm losing you. I don't know what is happening.
Okay.
Okay. I'm back. I see. This is a well-known picture showing how, this for industrial revolution, what are the key characteristics and how this happened in time. I will skip this. I won't go into the details, but what is important is this curve, that how the complexity in manufacturing system is changing from, let's say, moderate complex systems or organization of work in Industry 1.0, that means less craft production, towards Industry 2.0. I don't know why this is not following what I'm changing here on my slides. It's not following on the screen. What you are seeing. Can you help me with that? But anyway, the complexity is now rising exponentially, and we have to be aware about that. We were in our lab, we were aware about that for two decades, and we were developing some solutions, and we were investigating how to deal with the complexity. Of course, it is also an interesting topic for the future. So I was talking about the changing role of a human subject I'm really wondering why the slides are not changing on the screen. Or is it frozen? Do you see?
Yes, the slide is changing. You are now at the shining role of a woman subject in MS.
Ah, okay, because I don't see it on the screen. It seems that this okay. Picture is frozen. Thank you. Okay. So what is the changing role of the human subject within these 4 industrial revolutions? If you look at the first industrial revolutions, so all the job was done by a worker. That means the physical execution of processes, the physical work. The humans were introducing their power into the process. And of course, due to some organization, they have several people on multiple levels. The second industrial revolution, the time of Taylor and Ford, brought machinery and brought us much more effective organization of work. And the people were just, how to say, managing the machinery. What is bringing us the 4th revolution? It's bringing us controllers, computer-controlled machinery, programmable controllers, and it's bringing us agents, which will be doing a lot of work for the humans. And the human is being, is becoming more on the distance toward the process. He doesn't need to follow the process from the very close environment. He can, of course, manage his work over internet and so on. So this is very important change. So the humans are very important and must be there, must be presented, but their role is much different. That's why we are talking about the changing role from physical workers toward, from workforce toward the knowledge force. This is what is meant behind. So the vision of the factory, I borrowed it from one of the studies. What is here really important is connection. Everything is connected. Everything is connected horizontally and vertically, and that's why information flows are established, data are being collected, but there are also some new technologies like additive manufacturing, like autonomous vehicles, like collaborative robots and so on. But there are also new things which are important, like security, cybersecurity, data security, cloud computing, and so on. These are new things which are being developed or necessary in Industry 4.0. What is also important, we have to be aware that, you know, if we want to implement Industry 4.0, we have to invest. We have to invest, but there are also big expectations in return of investments. So, but without investment, there won't be any change. Okay, there is another picture borrowed from some literature showing us European countries in 4 groups. which are the front runners in Industry 4.0. Of course, we can see Germany in the front line, Switzerland, of course, as well, Scandinavia, Sweden, Finland, Ireland, so on. But there are also some traditionalists with high manufacturing share in GDP, like Slovenia. Slovenia, we are here. We are trying to follow these trends, but still, you know, quite with a gap. What are the key technologies? I avoided here in this text what we were addressing in as key technologies in our lab. Connectivity, first of all, connectivity. Everybody and everything is connected. The industrial Internet of Things, the social networking, work over web conferences, and so on. This is the case. The network within supply chains or supply networks is also a key technology. Additive manufacturing, advanced materials, these are more traditional things, and digitalization and cybernation of processes and systems. We are a lot talking about digitalization nowadays. That means, you know, transformation of processes toward, you know, computerized processes. But in industry, we cannot computerize everything. I mean, not everything is in information and information flows. We have to deal also with material flows. We have to deal with material transformation. So we cannot digitalize that, but we can cybernize. So that's why we are talking about cyber-physical systems. That is the system which is combining the cyber and physical worlds, and also the social world. I will show you some concepts later on. There are, of course, developments of robotics, autonomous vehicles, Internet of Things, big data. We were also working a lot on big data because we started our approach toward Industry 4.0 before this was known. That means 15, 20 years ago. First, by starting to collect data in industry, because at that time there was no data. Computerized, of course. There was a lot of data on paper, but not in computers. But to deal it as big data, we need first to collect the data. So that was our, let's say, objective for a long time. Okay, I will skip this because it's too much detail. What is about digitalization and cybernation and how cyber-physical system is defined. You can read it. I already sent my slides to Professor Mpofu last night. But okay, I can show you on this figure what does it mean. So digitalization means that we develop a digitalized function based on a digital mechanism, that means an algorithm or whatever, and that we convert digital input, information, into digital output. So everything is within the digital world, in computerized world. So we are dealing with digital information flow. But there is a lot of industries which really work like that, like banking. Of course, they also have to make some money flow, cash flow, but it's being decreased. Or what else? Selling of air tickets, flight tickets, and so on, or making reservation, booking of hotels and so on. That's everything digitalized now, and running over platforms, application, and so on. But in industry, we have to deal with materials flow as well, and we have to do the material transformation. So the inputs are not only digital, but they are also material, and the outputs as well. So not only digital, but also material outputs. But we have to deal with perhaps digital mechanisms which are implemented in the controllers. But there is also a human subject which has to be somehow involved in the process. So this is the main difference between digitalization and cybernation. and which we, in manufacturing, we should know and recognize. Okay, about networking, I don't want to speak too much, but it is also one of the key technologies, the convergence. Okay, I will skip this. But now I will talk a little bit about our approach to manufacturing systems. We are considering manufacturing as a system. That means that we need some system tools to deal with the systems. So, and there is the nice relatively new science, which is called cybernetics, and which was developed by Norbert Wiener in the late 40s of the last century. And he named it as a study, the scientific study of control and communication in the animal and in the machine. So the animal and the machine. Animal includes also human subject. We are not supposed to be animals, but okay. I think he was considering humans here as well. And the machine, of course. So he's combining, you see, he already at that time combined the physical and the social worlds. And it provides concepts which are highly relevant for the advanced manufacturing systems, like learning. In big data, we are implementing learning. Cognition with artificial intelligence, adaptation, social control, very interesting issue. Emergence of new things coming from the complex world. Communication, of course, very important for Industry 4.0. Efficiency, FSC, connectivity. So these are all the attributes we see in Industry 4.0. So that really point us out that cybernetic is the right approach toward manufacturing knowledge or science. So, okay. With this having in mind, we try to conceptualize a cyber-physical production system. What is interesting on this figure is that we divided the space, the common space, into 3 subspaces. The social space, where a human subject is, of course, acting. The physical space, where we have machinery, where we have logistics, where we have material flows. And in between, we put the cyberspace, the virtual space, where everything is connected. And we put in this cyberspace the so-called virtual work system. Today, some people are naming it as digital twin. Okay, we discovered this term, virtual work system, 20 years ago, when there was no digital twin, but okay, it's a very similar thing. And so this digital twin, you can connect your system, your manufacturing system, either it is a small or a big one, with other systems, to Internet of Services, to Internet of Things, and to social networks. So this is a kind of idea, how to divide and how to structure a cyber-physical system. And what is really important is this connectivity to almost everything. Okay, we have now we have to interface, we have to interface the social world with the cyber world, and we have to interface the cyber world, the cyberspace with the physical space. Of course, for that, for connecting physical space with cyberspace, we implement smart sensors, which are converting physical signals of physical quantities in a digitalized measured value. Of course, we need some smart sensors in terms of not just acquiring the signal, but also in processing the signal through fast digital signal processing and so on. But what we obtain on the output is a digital value. Of course, we need also some communication interfaces. Through these communication interfaces, we can communicate with the controller on the physical side and of course with the work system, with the digital work system on the physical side, or the cyber side. We also have to interface, the social space and the cyberspace. How a human can communicate with this system? You can see there are several opportunities, from very basic, from keyboard, mouse, joystick, and so on, to very sophisticated. You know what Elon Musk is now working on. It's about the reading of mind with electroencephalography. We did some experiments in my lab in the past, and it's very interesting. It's still a lot of work to be done, but that is how our future will be. Okay, I should skip this. Yes?
Yeah, I think you should be summarizing and rounding up,
okay.
So we can have room for questions.
Yes, here I have some examples of our work in the past. I can go through this perhaps somewhere in the future, but anyway, what we started with manufacturing execution systems already 15 years ago. It was a web system, so that we could connect to the system. That's the factory layout of our industrial partner, and we connected information. We extended it to welding, and welding is a manual process still performed by welders, attacking this kind of large workpieces. And we also connected it via wireless communication for collecting data from the welding station. Then we went to the die casting machinery, which is shown on this figure. We also implemented this in die casting machinery, and now we are collecting the data in die casting process. Each sequence, each cycle, we get some data, and we can analyze this data. We developed also a virtual reality system for showing in a submerged environment, in the cave environment, how the process is running. This process of centerless grinding, for example. We developed a reverse engineering system. Okay, and then we developed a product service system for hydropower. Also, we check company on that issue, and these are some very interesting results. Okay, now let me conclude. I try to point out what is the situation in manufacturing nowadays. And I also wanted to discuss a little bit the perspectives and opportunities in Europe regarding the manufacturing industries. I try to briefly present you what are the key issues of Industry 4.0 and what are the key technologies for successful industrial transformation. Of course, there was no time to show you a little bit more about the cases which we implemented in industry, but we have good experiences with this industry university collaboration, which of course we also know what are the problems, we also know what are the obstacles on that way, but I think it is really the way how to narrow the gap between the knowledge which we have at university and the knowledge which is available in industry. It has to be really narrow, this gap. So thank you very much. That was my presentation. Of course, my question would be, what could be next? And I'm available for some questions. Thank you.
Thank you, Prof. Butala, for engaging us in the last 20 minutes. And I think we can see the insightful work that is being done your university during your stay there, and I think we are benefiting from the Gibela research share to take some of this work forward. I think I will hand over to the program director that is in the workshop, because I have to intervene to do this since we are both online. Well, I think you can switch on your mic.
Thank you very much, Dr. Adenuga, and thank you very much, Professor Butala, for that detailed presentation. The question, yes, what is next? I believe we all enjoyed the presentation, but we're asking ourselves, are we ready for that improvement of production or productivity? Are we ready to apply all of the knowledge that we just got in order to improve our systems, or are we stuck on the obsolete concepts? Before we go to the questions, I believe we have questions, comments, or we are itching to just say something to Professor Butala, who is very far in Slovenia. And again, thank you very much, Dr. Adenuga, leading the online program all the way from Nigeria. Before we do that, we have new members that have joined us today from the industry. Prof, do you want to say something?
Prof, you can drop your screen, stop sharing.
I didn't hear. Was there a question for me?
No, you can stop sharing your screen so we can have the platform for others. Thank you, Prof.
What are the ingredients that have made this industry academia collaboration work in Europe? I think maybe you can highlight the ingredients that make it work and that may ensure that the technologies that are coming from the academia are moving into the industry. I saw that you had run through your slides the examples that you had, but that's really like what we wanted to get a sense of. Thank you. You can unmute Peter and respond.
Yeah, they can't hear us. They cannot hear. Oh.
Can you hear us online?
Yes, Prof.
Did you hear the question?
We did not hear the question.
Okay, I'll come again with the question. Is it fine now? There's someone here who's in the meeting. Hello? Can you hear me still, Dr. Adenuga?
Yes, you are clear now. But we still
Okay, super. So the question that I wanted to ask Prof. Butala is that, as you can see through our chair, we're trying to collaborate closely with the industry and develop technologies that must make their way and have an impact in industry, but also, like you were saying in your slides, help SMMEs be established and be functional. And the question that we are battling with here is the collaborators, the industry, and the academia is how to accelerate the transition of these technologies towards the industry. I know it's a slow process, like you said, when you were explaining the theories, but obviously for Africa, with the constrained resources we have, we cannot afford these extended periods of time to be investing on the R&D side and not realizing the potential of these technologies. So, yes, Peter, I don't know if you can hear me.
Yeah, I got your question. Yes, of course. Okay. Some echo, huh? What's going on? Okay, it's not an easy question. How to accelerate? I think you are on a good way because you established a research chair which is connected tightly to industry. That is certainly the first step, which is very important. You help to know each other. You help to work together. You help to develop the trust for collaboration. You hear me? Hear me? Hear me?
Yes, we hear you, and then there's a nice echo there.
Many times. I think you hear me many times. Repeating. Okay. If I repeat, so the first step is certainly organization of joint platform, which I see your chair it is. But then you have to select some projects, individual projects. You have to form the joint team of industrial people and students. And don't expect that graduates or undergraduate students will bring you new technology or innovations, but they can learn a lot. Those who could bring some new solutions are PhD students. They are serious, they are grown up, they are working for several years. But usually PhD students are working on their own individually. But you have to connect them in teams. So they have to collaborate to each other and to industry, sharing the idea, sharing the solution, sharing, the knowledge. And I think this is the big step forward to make it in teams. That's why I mentioned during my presentation that we develop a model for that. Students working in teams, because teamwork is very important today, not individual. I remember 30 years ago in industry, people, engineers, were working by themselves on their own, but they were hiding the solutions in their, tables or whatever, not to show this to the colleagues because that was their competitive advantage. Today, it must be much more open. You have to share. And you have also technologies which enable sharing, like collaborative environments where you can share data, where you can share solutions, drawings, and so on, but also thoughts in synchronous or asynchronous communication. On the other side, you need to gain resources. I mean, money, of course, because money is running the world also in the research and development. So, because you have to pay the students, you have to pay for the material costs and so on. But I think, as I know South Africa, and I spent some time in South Africa, in Johannesburg 10 years ago, there is a lot of funds, a lot of opportunities, especially if industry wants to give something, then the state is also giving something. And that is a very good mechanism. So not only that you are not only financed by the states, or not only from the industry, which industry is very careful how to spend the money, but you can win some synergy from, getting funds from both sides. And that is very important as well. Of course, what is also important is to be, online with the current knowledge. So really to see, to observe what the other world is doing. And also sometimes to copy some ideas, especially I mentioned these two role models like South Korea or China. They were, of course, they were copying. Japan was also copying 50 years ago. That's why they developed this industry for cameras, because they needed it when they were copying. In the States, the US industry, when they were copying the European industry and so on. So, of course, learn from, if it's possible, learn from the mistakes, but not your own, but from others. That is also one of the rules, I would say. So, but I think you have a very, very good basis with this research chair. And I noticed also that you already have some results, which are very, very interesting. And I have to mention that Professor Mpofu knows that. You know that my first international project I was involved in was in the 90s, a Eureka project, EasyTrans. It was dealing with the rolling stock industry, the same industry as you are in. And we were working with a German company, which was called at that time Deutsche Waggonbau. And it was from the east part of Germany. At that time, Germany was already united, but the company was from the east part. And I think it was the only industrial complex that was kept. All other was, destroyed and built new, but this one was kept. 20,000 people employed. And they, in 4 years, they transformed this company into a modern company, but of course with putting a lot of money in it, of course. And when we had the last meeting of the project, we were seeing people from Bombardier, from Canada, making this observation of the company, because later they bought it. Later it was bought by, I don't know, other trans and so on. I'm not following anymore. But for me, it was very interesting. So, and the industry, of course, is also very interesting and very dynamic. And I see this industry have a big potential in Africa, not only in South Africa, because Africa is still not connected continent in this means. Okay, I was a little bit long with my answer, but I hope I made some points.
Thank you very much, Prof. Thank you so much. We will try very hard to apply that into our South African context. Before Professor Mpofu decided to ask the question, I was about to welcome and acknowledge the presence of more of our members from the industry today. So I want them to feel welcome to join the program, that we are continuing from what we were doing yesterday, and we hope you will enjoy it. We have amongst us Ntate Justice Chifularo. He is working as an executive manager at Productivity SA, and then he is a member of our advisory committee. Also, we have amongst us Ntate Thabiso Komako from Gibela. He's working as a manufacturer executive, focusing on industrialization. We also have with us today Ntate Ezra Bambo from Gibela. He's heading the process and manufacturing engineering. Thank you, welcome. Without further ado, can I ask Mr. Oh, sorry, he's a new doctor. Can I ask Dr. Oyesola Moses to come and do his presentation? Dr. Oyesola is going to talk about smart manufacturing, the word smart manufacturing, let me see, technologies of the future. It's a concept of data collection architecture for small and medium enterprises. Presentation, Dr. Oyesola.
Okay, good day everyone. It's an honor to stand before great mind to share my presentation, and we are going to see what's going to ensue. The topic before me has been stated as smart manufacturing technologies of the future. A snippet of a consensual data connection architecture for the small medium enterprises. So these are the presentation outline. I won't waste your time. It's just a kind of proposal. So the quest for digital solution is increasing day by day, and it is the present gold mine that we all have to key in. So as a result, also there is a shift in manufacturing system, a shift from the conventional way of manufacturing to catch up with smart systems. So in other words, what is smart manufacturing? Smart manufacturing can be typified. Okay. So smart manufacturing is a system to attain flexibility, connectivity, efficiency, safety, and security in a production system. We can imagine a smart manufacturing as a process at hand, whereby we have a kind of integration. And what enabled smart manufacturing system? It came about from the concept of Industry 4.0, where we have virtual reality, we have augmented reality, and the likes. Now, also, big data plays a big role in smart manufacturing. Also, additive manufacturing is a new concept that the manufacturing system that is required in smart manufacturing. So, more into the background of why big data, why data in particular. We've got concept of Internet of a Thing, where we have cloud computing automation system, then decentralized manufacturing, network control system when we are referring to advanced sensor, robotics, and additive manufacturing, IT skill and training. These are peculiar elements for the small, medium enterprises. So as we can see, what cut across all these elements is data. So data is very critical in the present day manufacturing. That has been justified in the presentation we just had from the prof. So the problem, the challenges the small medium enterprise face in a competitive environment is trying to metamorphose into present digital manufacturing of smart enabled system. So the transitioning becomes a challenge because for the big players in the manufacturing industries, it's so easy because probably funds are available, but for the small SMEs, they struggle to cope. And for them to remain competitive, it's so critical for them to have element of system that can capture data. So what are the objectives or aim in particular? There's a need to have a kind of a decentralized system whereby all manufacturing players can play their own role, even as small as it is small-scale intelligent systems of smart manufacturing technology that can be deployed into production system. So the objectives, as I stated, I don't want to take your time. So from the literature, especially whereby we have autonomous function, why the need for data for self-sensing function, self-adaptive function, when it comes to self-adaptive function, we have the cognitive and anonymous detection, then self-organizing function, self-deciding function for predictive and prognostic, as well as optimization. So the usual methodology for mining data is as displayed, and is so subjective to any business environment, depending on the business structure. So we need to determine what the objectives of each and every business is all about, and what they have access to, and also the reason for having data, and also the projection. It goes all the way to understanding, preparation of the data, modeling, evaluation towards deployment for their own efficient use. So the methodologies when it comes to academic environment, the element of how to manage the data itself. We've got different methodologies there, artificial neural network, anonymous detection, association rule learning, machine learning, data cleansing, regression analysis, on like that, to attain a knowledge discovery of process improvement. So that is the target of the methodology. All this methodology can be broken down from studies going forward. So for this particular study, it's like a conceptual model that trying to like, it will be blown up as time evolves. It's going to be based on the function and the attributes for why the need for data by having a level of that in an architecture. So where we have the level of smart connection, the information stage, the cyberspace, and the configuration stage, and whereby where to deploy all these things, all these elements. So for a business case, so this is a study where we are going to find application to case studies. And before that can be deployed in any small enterprise environments, we are going to start from the case study perspective of an individual venture. So whereby there will be a kind of laboratory information management system of a particular venture based on the client's requirement, then going forward to the data spreadsheet as collected, the instrument, then the methodology where the academic comes in is the analysis of the data and the result, so that that will be inform them and guide them towards predicting their business and improvement. So for this study, this is the proposed work plan for the study and how it will be taken, hopefully maybe in the next 2 years, and trusting that there will be a lot of publication out of this by the time we have a lot of case studies we can use as the testing ground. And even as this study evolves, there will be a team that will carry this project forward. It is a very critical project that really requires urgency. So, in conclusion, the scope of looking into this is just to achieve a practical solution towards a sustainable manufacturing environment, starting from the micro to the macro venture, and also in order to attain value creation network, improvements of product and processes, and efficient data architecture will be deployed. So in order to achieve real-time improvement with respect to quality, reduce lead time, reduce overtime, cost management, and that will lead to better throughput of a production system. This is where I will stop because of the time. Thank you very much.
Thank you very much, Dr. Oyesola, for that great presentation. I believe we will have comments from the audience or questions for Mr. Oyesola, Dr. Oyesola. Do we have? Can I see? Okay, let's start with you and then we'll go to Dr. Muvunzi. Let's start with Dr. Denyang and then we'll go to Dr. Muvunzi.
Thank you so much, Dr. Moses. It's such a very great and promising delivery. So thank you so much. My question is this, the issue of sustainable manufacturing now is, becoming a common name now within the manufacturing landscape. So I would like to ask, what are the components, that make up a sustainable manufacturing? What are the components that we watch out for before we can conclude that some aspect of manufacturing are sustainable? Thank you.
Before you answer that, let's get a question from Dr. Muvunzi and then you can give us a summary.
Thank you so much, Doctor, for the presentation, which is very relevant at this time. As you were presenting, I was just recalling about this documentary that I watched pertaining to the security of data itself. Like there are a lot of cyber criminals out there taking data and using it to their own advantage for fraud and the likes. And mine is just a contribution. It's not necessarily a question that maybe you also need to explore on the security side, since some of this information might be very sensitive. So it's just a contribution. Thank you so much.
Thank you very much. Regarding Dr. Daniel's question, sustainable manufacturing. It's simple. From the word sustainable, it must be a manufacturing system whereby there is a room for continuous improvement, and that does not eventually lead to obsolete system. There must be continuous improvement. That's why it becomes sustainable. I don't know if that answers you. Thank you, Dr. Muvunzi. The issue of data security is becoming a serious challenge, even for anyone that wants to maintain their data, security. So that's where this word comes in, like what was discussed yesterday, the issue of IP. IP is so critical, so IP can be used as a weapon to fight against data security. Thank you so much.
Thank you, Dr. Moses. Remember that we are going to have tea time, we're going to have lunch, we're going to have an award ceremony in the evening. So if you have questions that comes or comments, you can still ask Mr. Moses, Dr. Moses offline. You are very welcome to do that.
Thank you.
Yes. Tate Mabalani, this is your chance now to tell us about this development of a recycled carbon fiber reinforced composite All of this for the transport industry. Tell us. While he's connecting, can I please take this chance to remind you that coronavirus is still amongst us. COVID-19 is still amongst us. If you check in front of you, there are safety notes. You can remind yourself by reading them and then applying all the precautions. And remember that outside we also have guests who are here for other activities. So when we mingle, when we move around, let's remember to put on our masks and follow all the precautions. Thank you. Please take note that if you want to use your laptop for the presentation, make sure that it has got a slot for HDMI because we don't have VGA cable. Or if you don't have that, you can bring a memory stick with your presentation in so that you can connect. Or you can just put your presentation in the folder provided before time so that we don't waste a lot of time. Thank you.
Good morning, each and everyone. My apologies for not having the latest laptop. I will have it one day. My presentation is all about the techno-economics and the developmental of the carbon fiber rope reinforcement polymer. So this is my presentation outline, of which is introduction, aims and objectives, industrial business case, methodology, the expected outcome. Okay, I'm a PhD candidate, so basically this work is just a proposal for my PhD. So the reason that I developed this study, it was because of when I go deeper into the literature or deeper into the transport sector, you find that weight it's a very crucial challenge that is happening because of when you have too much weight, you have high usage of fuel, and then high usage of fuel, it can lead to many factors such as the project not being viable. And also now, so the weight, it can also be related to the carbon emissions, like in the transport industry, the automotive industry. So like we have an instance where like, if the weight is too much, related to acceleration and deceleration. So it yields the carbon emission and results into the greenhouse gas emissions. So now the world took a transition whereby now it has to focus its own research now into the light weighing application. So now for this instance now, for the purpose of this case study now, I've decided to use a boogie to see that how can I reduce the amount of energy and also the amount of weight. So now, so this boogie, it is made out of steel or the cast steel. So how can we replace that, or how can we shy away from the fact that we are using steel? So the only thing that it comes with good properties, good mechanical properties, good physical properties, good tensile properties. So that can be compared to a steel. It's a carbon fiber reinforcement polymer. So this carbon fiber reinforcement polymer, they are using it very wisely in France, whereby they've incorporated it into the rail sector. So now, one of the guys there, they've made the boogie using the carbon fiber. So the only drawback that we have, like in the carbon fiber, it is that carbon fiber is costly. So how can we mitigate the fact that the carbon fiber is costly? Number one, it is reported also in the literature that in the aerospace industry, after certain years, we know that in the aerospace, that is where the carbon fiber, like, it dominates. The planes, like, they are made of carbon fibers and also with the glass fiber, so it's a hybrid of the two things. So after a certain time now, it gets to a place whereby it reaches its own shelf life. So now, it gets decommissioned. So that is where now the knowledge, it came to say that, how about we do what is called the recycling of the carbon fiber? The recycling of the carbon fiber from where? From aerospace material. So by doing that, we are doing what is called the integrated environmental system, whereby we are taking care of our landfills based on the commercial sector. So now, today also now, the BMW and also Mercedes-Benz, they've also ventured into the market into the usage of the carbon fiber. So they're also using it also to manufacture some of the tools that are used in the engine. So as you can see there on the diagram there, is a visualization to say that it starts from the carbon fiber. So from the carbon fiber now, they produce what is called the planes. After they produce the planes, we have the decommission state. After the decommission stage, so that is where now we reuse it, those carbon fibers to produce the boogie. So now, to eradicate the cost implication, that is where now to say that during the decomposition stage of the carbon fiber, we have a process whereby it is called the lowering of the mechanical properties of that carbon fiber. So now, one of the objectives that one has to come up with is to always keep the mechanical properties of that carbon fiber into a good place. So now, I've come with a scenario whereby now I will use the hybrid study of what? Of the carbon fiber and also the recycled. So I'm going to use it both. So to eradicate the issue of the cost implication, so that is where now one will have to apply the mechanism of doing a cost estimate analysis, whereby I will conduct a feasibility study. During my master's, I've done the modeling. I've done the modeling and simulation for the process of anaerobic digestion. So using that modeling, I will just put the data that I will have during my characterization and then put it into into the model that I've designed, so that I can determine the feasibility study. So the aims of this study is to develop the reclaimed carbon fiber for the design of the panel for rail and also automotive application. So initially when I conducted this study, I was conducting this study for the usage of the carbon fiber wheel. So, so that is where, when I joined the industrial guys, so that is where now I thought, let me just go deeper to say that and see how can this carbon fiber be applicable into rail. So the first specific objective, I'm going to do the organic decomposition of the epoxy resin. The epoxy resin that is reinforced within the carbon fiber. And the second one, I will have to study the conditions, such as the concentrations and also the types of the solvents that I'm going to use in order to do my decomposition. And also, to study the surface microstructure, because of now, okay, I will explain in the methodology. Also to study the surface microstructure through the scanning electron microscope, and also performance of the TGAs and DSCs to evaluate the contaminations. Lastly, to develop what is called the techno-economic model to see whether my study is it feasible or not feasible. So the business case. So one of the business case that I thought of when this project is successful, when I test my panel that I will develop, whether it meet the certain specification for rail and also automotive industry, like for the application of the carbon fiber wheel and also for the application for the bogie. So after I'm going to test it. So now, so if it is successful, I will be able to develop the production center. I will be able to develop the production center, so whereby now we'll be able to produce these parts in large quantities. And also, if I'm also successful, because of now, this process is a recycling process whereby it focuses on composite. So I will be able to open up a composite innovation center whereby I will invite people who are using plastics and everything to incorporate my carbon fiber into the plastic to enhance certain mechanical properties of their expectations. And lastly, and open the reclaiming plant for the carbon fiber reinforcement. Because of like in the carbon fiber reinforcement plant, so that is where we use the chemical engineering techniques such as the fluidized bed and also certain amount of solvent. So it's a chemical engineering process. So that is the last one that hopefully one day I will open. So my methodology starts from here. So I will start from the pre-preg. So the reason that I'm starting from the pre-preg, I'm simulating conditions for my, like not simulating like doing a model, but simulation like making the same situation for something. So I want to simulate the conditions for my carbon fiber, of which it will be a pre-preg. The reason that I'm doing this, this simulation, it is because of, you see, like when you have a plastic, each and every plastic behind it, like those bottles there, underneath, they are written PET or something, PP or something. So it is the type of plastic that is used. So unfortunately for the carbon fiber, the one that I used, it is not specified. So my study won't be, so if I want to develop a testing mechanism to see the reliability of my study, I have to do a simulate. So now my simulate, it will come from the pre-packed carbon fiber that I will purchase from the AMT. AMT, the one that we have in Centurion there. So I will prepare it into the autoclave. After preparing it into the autoclave, I will cure it at a certain temperature of condition. So, of which is now I'm curing them at 120 degrees Celsius at 0 pressure. After I cure it, I will then put it into what is called the weathering machine. So the weathering machine is a simulating machine that is able to simulate the external environment to do the evaluation of UV. Because of, remember, when something is being recycled, it has got, you must always see the effect of the surrounding, of the external factors such as the UV, how it behaves. So I will check those things. And also there, after I have put it into the weathering machine, I'll then put it into the batch reactor now. Into the batch reactor, that is where now I will do the decomposition of the reinforced polymer. So I want to separate the epoxy that is reinforced within that carbon fiber, with the use of the supercritical carbon dioxide. The reason that I've written the supercritical carbon dioxide, it is because of I'm using extensive temperatures, such as about 300 degrees Celsius and high pressure, obviously. And then I'll be monitoring my control variables there. As I've mentioned, I'll monitor the pressure, concentration, also the retention time. How long does my epoxy into the carbon fiber gets decomposed? So immediately after the batch preparation, it goes to the characterization. After it goes to the characterization, whereby I will do the DSC and also the TGA, the scanning electron microscope, and also XRD, just to determine the amount of impurities that are there into the carbon fiber. And lastly, I will perform the mechanical test. So these mechanical tests are crucial now. So I will perform the impact test, and I will also perform also the single fiber filament, whereby now I want to see that is there any deterioration of that single fiber, and then I will then perform with all the control variables that I will be having now. I will then conduct what is called the techno-economic analysis, whereby now I will focus on the net present value and also perfect index, the internal rate of return, and also do the performance of the sensitivity analysis to see how does one gets affected when gets to a change into any variables. Last, and also do the performance of what is called the LCA through the open LCA software to determine the environmental impact assessment, because of I don't want to be employing something that is hazardous to our environment, so I need to determine those key factors. So as I was saying now, remember from the initial state on the objective, I've mentioned that I want to develop what is called the hybrid of carbon fiber and also recycled carbon fiber panel to be used in a carbon fiber wheel, or to be used in a bogey application. So I need to at least maintain between 90 and let's say between 90 and 100 of mechanical properties. I think my presentation, it ends here. Okay, so my acknowledgement, I'm from the chemical engineering department, the polymer engineering department. So I would like to acknowledge the Tshwane University of Technology, meaning that the industrial engineering department, for giving me this opportunity to join them, because of us from the polymer engineering and also the chemical engineering. I think we always suffer a drawback of how to industrialize our research. So the reason that I'm here is to get the key factors on how to industrialize our research with all the key fundamentals that we have learned from school. So, and also I thank you all, the Gibela guys and also the NRF guys. Thank you very much.
Gibela guys, they say thank you to you. And the NRF guys. Thank you very much, soon to be Dr. Mabalani. Thank you very much, Mr. Mabalani, for the presentation. I don't know much about polymer, I don't know much about these new materials, but that's a lot of work that you want to do right there. There's models and models and tests and tests and tests. So do we have questions from the house? Ooh. Okay, where do we start? Should we take all three and then are you taking notes, Dr. Mabalan?
Listen.
Maybe they can buy you a new laptop. You'll never know.
Morning, everyone. The topic that you touched on, Mr. Mabalan, it's quite interesting, especially for me. Obviously, coming from the railway sector, you've touched on a point that has a huge impact on the overall train on our side, okay? So I made, as you were busy presenting, I made a couple of statements. Most of it is just statements that I don't know if you've touched on it or you're going to touch on it. So there's advantages with what you want to do, of course, and I named them here. You've touched on the reduction of mass, right? That's quite important on a train. You didn't say anything about energy saving. There is a huge part of energy saving. The big one that we tend to measure as well when we look at bogies is the track force. So the amount of force exerted on the track that the train runs on. That as well is quite a huge improvement that this will bring in the railway sector. Now, there's also, when I read about this, there's also thinking of the monitoring of the temperature of the bogie itself. Now, with fiber optics and temperature sensors installed in this type of model, will help in monitoring the temperature of the bogie itself. And I take it when you present an idea of such, you're talking about, on a bogie itself, you're talking about the framework of the bogie, not the wheels in carbon fiber. That's what I would think that's the line that you're going in. And with that, you have the opportunity of, as I said, maintaining or measuring the temperature on the bogie. That as well in maintenance is quite important for us to know how it behaves while it's having different types of loads in different conditions, especially in South Africa with all types of weather. Whenever we talk about bogies, we always talk about two things: stability of the bogie and the safety analysis of it. So if this is going to improve those two, I can tell you it will bring huge interest in all sectors. It might not only be in railway, in automotive, coming to your chassis. That is quite critical. So quite a lot of work that needs to go into this. I can only wish you good luck, and I have huge faith in such material, and all the best. Thank you for the presentation.
Thank you very much, sir.
Before the next question, can I say the hand online, we see you, and then you will ask your question after Mr. Mabalane has addressed the first two issues. Thank
Okay.
you.
Yes, thank you very much for the comments. Yes, as you can see on the second diagram, I doubt you can see there. When I say the structural test, the structural integrity test required. So now, there I spoke of impact test, and I also spoke of compression. I also spoke for tensile. So when you speak about the force that is that our boogie required to handle on the train, that will be on top of it. So that is applicable to the compression. So now, it's just that I did not go deeper. So with all the instruments or the characterization results, I will then employ my characterization results into the finite element analysis to see the behavior of how can this behave in a real world. But however, some of the comments that we have mentioned, I will also take them into consideration. But for the one of the force, I did took it into the consideration because of it is one of the critical components that one needs to take it into consideration, because of if it goes wrong, the whole thing is a boom. So thank you.
Thank you. Let's get the next comment in the
Okay.
house. Thank you.
Good morning. I'm actually smiling because this is one project that's really, shifting us, from a traditional way of thinking, from our industry. Having been, working with trains for almost 20 years, I must say it's a breakthrough initiative, and I really have goosebumps, and I'll be following you very closely. I just have one question, and my question is around, as well indicated, with our industry, product safety is very important because we carry human beings, I just want to know whether, in terms of your scope, are you limiting it to passenger rail, freight rail, and moreover, from a technical submission, I would like to understand your validation model. How are you going to validate this initiative in a dynamic, environment?
Okay, thank you very much.
Sorry, Mr. Mabalani, please don't take that one. Let's take the next comment, and then you will address all of them.
Okay, Luvuyo here. So I think my question was partially asked and answered by yourself with Mr. Mbambo and Kumako there. But I have another one. So with this transition from our traditional materials with now the carbon fiber, I just want to know what is the impact long-term on the maintenance of now specifically the components that you want to switch from stainless steel, iron and the likes to carbon fiber? What is the long-term maintenance cost impact on those materials or components? Thank you.
Okay, thank you very much. Yeah, since well your question, I will end with you. Yeah, let me start with you. Say, okay, first of all, remember that steel, it has got its own drawbacks. The drawback number one of a steel is rust. Rust and also corrosion with respect to the reaction of oxygen. So now, with respect to the carbon fiber, so the carbon fiber does not react with any oxygen, and it is also UV resistant. So the only condition that you can find in a carbon fiber is that it can break if it does not reach the required amount of force. But however, if it reaches the required amount of force, you are certain nothing will happen unless otherwise the lifespan of it comes to the end of life, and of which it can take about 50 years. Thank you very much. No, thank you very much for your question. So your question,
Hello.
Yes.
My
Let's go.
mine would be like another. Okay.
No.
I thought it's done.
I'm not done. Yes, I know. I want us to discuss your question over lunch, say, because of you know, your question is very fruitful to my mind, and it's very fruitful to my thoughts. So I don't want to answer you, and then I will think that I've answered you, then behave that I've answered you. But later when I'm at home, it catch up with me.
No problem.
So I don't want to be in that situation.
Thanks for the honesty.
Yeah, thank you, sir.
Take it offline, Ntate Mabalane. Do you have another question in the house? Okay.
Hello. Mine will be a kind of a comment. Then I think you should know that the process route has a long way to affect the property of the material. So you have to really do a kind of an extensive research on the process route you are going to apply, because it will also affect the microcomposition of the material. Then when you talk about the replacement of carbon fiber to steel, which is in use, you know, the key critical factors you have to really consider is about weight. You know, fiber composite has less weight. And when you're talking about, when you are putting it or letting it to transport, you are talking about payload, which will go a long way to manage energy. But if it is fuel, it will reduce the fuel consumption rate of the train. Then that is all I want to say about it.
Thank you, Mr. Ua.
Okay. Thank you very much for your comments. Remember that the objective, it is not to reduce the weight by 100%. As long as we can have a weight reduction of about 50% of the initial state. So that's a reduction, and that is a past project for me. And also on the study of the microstructure of the project, I've taken that into consideration. Depending on the type of the material that I'm going to use of now, which is in this case, I will be incorporating what is called the biosphenol, the type of the epoxy resin that I'm going to use. So it is very competitive. So you find many of the commercial industries, they are using it. But however, I will still do extensive study, also into studying different types of material that can be competitive to others. Thank you very much.
Thank you. Good presentation. However, I have to apologize. I was not really tentative from the beginning, but I see where it's going. But I think that maybe the colleague is more talking about the weight of the train, not necessarily the weight of the bogie, because the bogie needs to carry some weight of the cars. Just pause on that part. And I think earlier on there was a speaker, our keynote speaker in the morning. He spoke about working as teams, collaboratively. I think you might need to engage a little bit with the mechanical department on this project, because I'm hearing that there's a lot of around how the composition of this material will work. I'm asking myself in terms of simulation you speak about, that you're going to do finite element analysis,
And I'm asking myself, what about the criterions? What are the criterions you're going to apply in your conditions for doing the simulations? Do you have a benchmark of mechanical, of the stainless, of the steel, carbon steel material that has been simulated? And also knowing that simulation tools gives you different results. You're not always gonna get, depends on how you apply your boundaries, how you apply your what is this tool that you're using, your meshing and so on. So how are you going to control your simulation? It might not be something that you have the answer now, but I think you really need to work closely with mechanical teams. And also what you need to also think about is practical application of this kind of a bogie. Given that it has to live the same life as what we expect the train to have, which is about 40 years. So are we talking about something that you will have to exchange at some point? Is it something that will last as the bogies we have today, traditionally? But all this, what I'm saying is not to discourage you. It's just to say that you need to think about practicality of this study.
Okay, thank you very much. Thank you very much for those comments and also questions. Let me take you back to the aerospace sector. So, the end of life of an aerospace, it takes about 40 to 60 years. Each and every plane, after 60 years, it gets decommissioned. Due to that, the carbon fiber start to lose its own mechanical properties and also other things related maybe to the mechanical properties of engines and other sort of. So now, so what I have for now, I've got a stainless steel. So that stainless steel, I got it from the brains. What's that company? From the, okay. So those people, they are producing a wheel. They are producing a carbon fiber wheel. So they've given me a data that they were using to compare the carbon fiber wheel with the conventional aluminum wheel. So so since the Gibela people are here, I think maybe it would be better for me and also a good opportunity if you can invite me to your company, whereby you can provide me with the material that is used to make that bogie, and then I do my comparison, the real comparison, without doing a simulation, but like not having the actual values from the actual component. So I think it can present me a very good opportunity, since this project is also, it can also bring good opportunities to your company and also improvement to your company. So I think it's a very good project. You just need an embarking on. Thank you.
Thank you very much, Mr. Mabalani. There was a hand initially online. I don't know if we still have that hand. Do we still have the hand online? I think it was Musikwa.
Musikwa will ask me a question over tea. Thank you.
I see you are speaking, but we can't hear you. Do you still have a hand? And I think Dr. Adenuga as well might be having a question.
Online.
I'm not sure, we can't hear
There's
them.
nothing online.
They're talking. Can I see a hand if there's a hand online? But at this moment, we can't hear you.
It's not there.
It's not there. They are muting and muting. So that's why I was thinking. But either way, Mr. Mabalani is not going anywhere. You can still communicate with him. He's usually at Ditsila. You can contact him or maybe write your question in the comments here on Teams. Then he can address them later. Thank you very much. Thank you so much, Mr. Mabalani. Maybe you'll get yourself some data to test your models. We don't know. Okay, moving forward, we are supposed to have a presentation from an online speaker. I just need to confirm, do we have Dr. Aderoba online? If not, I'm hearing myself many times like Prof. Butala. Do we have Dr. Ogbodo online? Either Dr. Aderoba or Ogbodo, do we have them online?
Nothing.
It doesn't look like. Can I ask Dr. Adenuga to type what you want to tell us, because we cannot hear you from this side? And again, do we have Dr. Aderoba or a Dr. Ogbolo online? Are you ready for your presentations? Okay, it seems like none of them are online, but Mr. Mabalani, your question is written here from MM Musikwa, I think. It says, my question to Mr. Mabalani is one, what is the yield of carbon fiber recovery from the recycled one? And then question two, any feasibility study on upscaling to production process? Do you want to address it or do you want to?
No, I can address
Unfortunately,
it.
she's not here for lunch.
No, it's fine. I can address it. Me and Musigo, we speak the same language, so. Can you repeat the questions again, please, on the yield?
Question number one, what is the yield of carbon fiber recovery from the recycled one?
Okay. So usually during the carbon fiber reinforcement, like with polymer. So like we normally, like when it comes like like there's a material safety data sheet form that is written. So most of carbon fibers, like there's written about to say that the MSDS it's about 30%, and the carbon fiber is it's 70%. So now carbon fiber now, it can only decompose at a very high temperature. High temperature such as where it's about 400 to 500, where those carbons, they will break. So remember that the mass is never destroyed. It can only be transferred to one place to another. So now in this case, it will be a mass balance. So if you have a 60% of the carbon fiber from the initial state, after the decomposition, you will still have that 60% of the carbon fiber, unless otherwise you are running your conditions at a very high temperature, whereby those carbons can break, those carbon chain within the carbon fiber, they can break. So for now, it all depends on the MSDS and also on the initial stage of that carbon fiber. So if you have the carbon fiber as 60% initial, you'll also recover that 60% of it. And the next question?
Any feasibility study on upscaling to production process?
Yes, remember so that is one of the objectives. One of the objectives is to develop the techno-economic model, whereby now I will determine the viability, whether this project, is it viable or not viable, depending on the return on the investment of the project. So now, this is it's an ongoing study that I'm trying to determine, because of I don't want to do something and then take it and convince people that it's doable, and then you find that project is not cost effective. So it's part and parcels of the
of the objective of the study. Thank you very much.
Thank you, Ntate Mabalani. I hear tea is ready outside. And we've been sitting for quite a long time now. Can we take this opportunity to grab a cup of tea? And then when we come back, we are going to have a panel discussion from our Gibela guys. We're going to have a panel discussion from our Gibela team. Yesterday we had a lengthy discussion about the opportunities that can be there, the assistance. We talked about sponsorships. So at the end of the day, we said, okay, maybe let's sit and discuss the opportunities that our researchers can get from the Gibela team. So can I give us 10 minutes to grab a cup of tea and then we come back? Unless if, I don't mind. I don't mind at all. It's just outside. Can use either this door, that door, or the other one, and then let's enjoy tea, come back and discuss the beautiful opportunities. All the presenters that are going to present from now, this is a memory stick that you need to put your presentation in, I was told. So it's a direct order. Thank you very much. Enjoy your tea.